Good afternoon, ladies and gentlemen. My name is Moon-Kyu Lee from Seoul, Korea. I'm an endocrinologist working in Ulji University in Korea, and I'm currently serving as a chairman of IDF WPR. And today, I feel very pleased to be invited to give a talk entitled as Role of DPP-4 Inhibitors in the Management of Type 2 Diabetes in the Era of Cardiovascular Outcomes Trials to this outstanding Congress of Philippine Society of Endocrinology, Diabetes, and Metabolism. I'd like to, and I'm going to talk in these sequences. And I'm sure this cartoon is very familiar to you all. As shown in this slide, the number of people with diabetes has been and is still increasing tremendously, meaning that the global impact of diabetes is likely to continue increasing considerably. But the thing is, the real importance, the seriousness lies in this area, depicted in purple color, that is Western Pacific region, where we belong to. We have the biggest number of people with diabetes, and we'll also have the same biggest number. As shown in this slide, the risk of mortality and cardiovascular disease is very highly increased in people with diabetes. As shown in this slide, there's mortality and hospitalization for cardiovascular diseases as well. You may remember some years ago, there's a publication of meta-analysis of cardiovascular risk of rosiglitazone, after which the US FDA issued guidance and requirements to assess cardiovascular risk with the newly developed anti-diabetes drugs. And after that, these are the completed and still ongoing cardiovascular outcomes trials, to name just a few, such as SAVOR-TIMI, EXAMINE, TCOS, CARMELINA, and CAROLINA, to have more recently introduced DAPA-CKD, etc. Let me introduce some of the summary of cardiovascular outcomes trials. These are the very early major trials. These cases were not mainly focused on specific drugs, but these, most of them are aimed at seeing the effects of intensive glucose control in case of type 2 diabetes. As you know, DCCT and UKPDS showed important preventive effects of metabolic control at the very initial stage of disease onset. But other studies, such as a CODE study, showed significant increase in cardiovascular mortality in those assigned to intensive diabetes management. Thereafter, there has been some update and change in the major guidelines, and as shown in this slide, the 2021 ADA update, the standards added several new evidences from recent cardiovascular outcomes trials or heart failure, such as below. For example, Carolina trial has been added, Pioneer 6 trial, and Credence and DAPA heart failure trials have been added to the most recent ADA update. You may be familiar with that already. And this is the DPP-4 inhibitors from SAVOR-TIMI to CARMELINA and CAROLINA. Carolina study has been added to the recent ADA update. It was the study comparing the cardiovascular effects of linagliptin versus glimepiride, and the result was non-inferior, mostly comparable results in terms of 3-point MACE of 0.98. In case of GLP-1 receptor agonist, as shown in this slide, the LEADER study showing liraglutide effect, SUSTAIN 6, showing effects of semaglutide, Harmony outcomes trial showing effects of L-glutide, and Rewind study showing effects of dulaglutide. Most of them showed significant reduction in the primary outcomes measured either by 4 or 3-point MACE. And the recently published Pioneer 6 study, which compared the effects of oral semaglutide versus placebo, the results was non-inferior in terms of 3-point MACE. The Pioneer 6 trial, the result of which is also added to the recent ADA update, as shown in this slide. What about SGLT2 inhibitors? Credence and DAPA heart failure study was added to the current ADA update, and these are some interesting stories because they showed, in addition to the cardiovascular outcome, they also measured the renal outcome as well. And quite interestingly, there was a significant reduction in the cardiovascular death or heart failure hospitalization in addition to the 3-point MACE. These are all adopted by the ADA update these days. So as a whole, in case of DPP-4 inhibitors, their cardiovascular safety outcome trials in patients with established cardiovascular disease showed they are not associated with any additional cardiovascular disease, cardiovascular risk as a whole. So this cartoon is also very familiar to you, I'm sure. And the most recent one was a little bit updated, such as shown in this slide. They divided, compared to the last year's ADA recommendation, they divided those risks associated with heart failure or CKD, but the basic principle is same. Such as in case of reduced ejection fraction patients, they recommended SGLT2 inhibitors with proven benefits in this population. And in those without indicators of high risk or established ASCVD, CKD, or heart failure, the recommendations still is maintained at the same level, including every one of these: DPP-4 inhibitors, GLP-1 receptor agonists, SGLT2 inhibitors, and TZD, etc., etc. This is another one, such as ACE guidelines, which were published last year, but the principle of cardiovascular risk reduction was also added and adopted by this guideline as well. So they recommended, independent of glycemic control, if established or high ASCVD risk and or CKD, they recommend very highly SGLT2 inhibitors and or long-acting GLP-1 receptor agonists as shown in this slide. I think you are very familiar with these recommendations as well. And this is the more specific explanations for each class of anti-diabetes agents. Such as in case of DPP-4 inhibitors, the interesting thing which should be focused is the dose adjustment necessary in case of renal dysfunction, but the linagliptin was an exception. So then, what about the clinical benefits of incretin-based therapy? In this case, DPP-4 inhibitors in particular in patients with type 2 diabetes. I'm going to summarize a little bit on this issue. This is a very well-known cartoon as well. And GLP-1, one of the incretin hormones, has diverse, numerous physiological actions. But the best elucidated roles are related with islet functions, such as stimulation of insulin secretion and or biosynthesis and beta cell proliferation, in addition to the well-known effects on suppressive effects of glucagon secretion. But GLP-1 has very pleiotropic, diverse action, including kidney and CNS, as shown in this slide. I think it has a very big meaning in our in Asian populations. This slide shows the pancreatic beta cell function and mass issue. In UK-PDS, we've already noticed that at the time of the type 2 diabetes initiation, almost 50% of the beta cell mass or function has already been decreased. And as time goes on, there's a gradual decrease in beta cell mass and function. So beta cell function really matters in case of Caucasian populations with type 2 diabetes as well. And there's a spectrum from normal glucose tolerance to full-blown type 2 diabetes. And these are the well-known risk factors and mechanisms of beta cell dysfunction, such as glucolipotoxicity, ER stress, inflammatory and cytokine reactions, autophagy, etc., etc. And what about DPP-4 inhibitors? The practical issue is tolerability. You know, DPP-4 inhibitors generally are associated with fewer adverse side effects, thereby placing them among preferred second-line options in many treatment guidelines, including ADA, EASD consensus guidelines. They are described as generally well tolerated. I think you may be very familiar with this. How about in older adults? You know, aging is a very serious problem worldwide, and there are some physiological changes in older populations. And in case of DPP-4 inhibitors, the cardiovascular effects are neutral. And the thing is that DPP-4 inhibitors are convenient for oral use. And the important thing is that we have to remind that renal dose adjustments are very highly required, except that they are relatively very safe and useful agents for use in older populations. I'd like to comment a little bit more on this issue compared to the last year. This year's ADA recommendation specified the A1C classes, such as 7.5 to 7.5%, 7.0 to 7.5%. And as to the very complex and poor health classes, they put down like this: avoid reliance on A1C. Glucose control decision should be based on avoiding hypoglycemia and symptomatic hyperglycemia. So I think they are stressing the importance of individualization in case of this kind of friable population, such as older patients with type 2 diabetes. This is another study which I'm going to introduce. It means that there's a study. This is an observational study comparing DPP-4 inhibitors versus conventional oral anti-diabetes agents. The baseline populations are similar among two groups, and the common reasons they found for DPP-4 prescription are preferably favorable efficacy, ease of use and prescription, no weight gain at all, and less hypoglycemia, which are very important for elderly populations. This is another interesting story on the DPP-4 inhibitors. This is a study measuring during the hypoglycemic clamp. They measured glucagon levels during the postprandial period and during the hypoglycemic clamp. You can see in case of sitagliptin treatment, the glucagon level is noticed to be lower compared to the placebo group, but during the hypoglycemic period, the glucagon levels between two groups became similar. So that can be a very safe phenomenon for prevention of hypoglycemia. And this is another characteristics of DPP-4 inhibitors. And this slide shows that in case of renal dysfunction, especially low GFR values, most of the drugs require dose reduction. But in case of gemigliptin and linagliptin, we don't need no dose adjustment at all, which can be very handy and useful. And there's an interesting story from a study from Korea showing the importance of inappropriate renal dose adjustment. They using the big data base. They measured inappropriate dosing group and appropriate dosing group. They compared between them in those with type 2 diabetes and CKD. And the main outcome measures are severe hypoglycemia, an emergency department visit, and mortality. You can see there was significant increase in risk of severe hypoglycemia, emergency department visit, and death in case of inappropriate dosing of DPP-4 inhibitors. There can be some explanation, many explanations for this, but they stress the importance of correct dose adjustment in case of renal dysfunction. This is a meta-analysis data in patients with renal impairment to measure the effects of DPP-4 inhibitors. You can see from the meta-analysis that DPP-4 inhibitors are effective in lowering A1C in patients with type 2 diabetes with moderate to severe renal impairment. This is another study showing the meta-analysis on the efficacy of DPP-4 inhibitors in patients with moderate to severe renal impairment. And you can see that A1C was significantly greater. Now, baseline, the change from baseline A1C, the decrease in A1C was significantly greater in the DPP-4 inhibitor treatment group compared to the control. This is another meta-analysis in terms of the risk of hypoglycemia. You can see from this meta-analysis that they have a potential of advantage in lowering the risk of adverse events such as hypoglycemia in patients with diabetes with renal impairment. What about the other beneficial effects? We can say that the beneficial renal effects are mainly through reduction of the risk of development or progression of albuminuria compared to placebo or other antidiabetic agents rather than prevention of end-stage renal disease or renal replacement therapy. These are the multiple potential mechanisms such as inhibitor enhanced levels of DPP-4 substrates such as GLP-1, stem cell-derived factor, etc., etc. But most of them are derived from the animal studies. So we need more study in case of humans. What are the peculiar and interesting effects of DPP-4 inhibitors in Asian populations, such as Philippines and Korea? You know, it's a very well-known fact that diabetes develops in Asian populations at a lower range of BMI compared to the Caucasian populations. As shown in this slide, South Asians such as Indians, Chinese, and black population show the similar prevalence, incidence of type 2 diabetes compared to white populations, as shown in this slide. And it's also interesting to see that at lower or equivalent BMI, type 2 diabetes in Asian populations have a higher prevalence than Europeans, as shown in this slide. The red line denotes the prevalence of Europeans, and the others are Asians such as Japanese, Chinese, and Asian Indians. The A1C lowering efficacy of DPP-4 inhibitors has been from several meta-analysis is known to be greater in Asian populations than non-Asian people, which could be mainly ascribed to Asian populations' relatively lower body mass indexes. And it's also important to stress the importance of visceral adiposity. East Asians, including South Asians, have a greater tendency to visceral adiposity. As shown in this slide, visceral adipose tissue masses are greater at a similar BMI in case of Chinese and South Asians compared to European populations. And this is also the reproduction of that data compared to Caucasians. Asian populations have significantly greater visceral over subcutaneous fat ratio in both female and male populations. The visceral adiposity has well been documented to induce serious inflammatory conditions, leading to increase in insulin resistance, which is a very important factor for the initiation of diabetes as well as the aggravation of it. Yeah, so we can summarize like this. Asians are usually characterized by relatively higher insulin sensitivity and lower insulin secretory capacity compared with Caucasians and Africans, as shown in this slide. Yeah, this is a very well-known data from Japan as well. And it is interesting to see that in Japanese populations, compared to Caucasian populations, similar degree of glucose tolerance, insulin secretory capacity measured by insulinogenic index is definitely decreased compared to Caucasian populations, we can see in this slide. Longitudinal data from Korea, we can see that as time goes on, over 10 years or more period, insulin sensitivity index usually decreases in any population, even in the non-progressors or to progressors to diabetes. Every group showed the increase in insulin resistance, gradual increase in insulin resistance. But compared to the insulin resistance, there should be some compensation in insulin secretory response. In those in non-progressor, their insulin secretory capacity compensates the decrease in insulin sensitivity. But as you can see in this green line, those which progressed to diabetes, they didn't respond. No significant compensatory increase in insulinogenic index. So I think this may be the main causation of the high prevalence, high incidence of diabetes in Asian populations. We can measure it as a disposition index as well. So I think I can summarize like this. The glucose lowering efficacy, including both GLP-1 receptor agonists and DPP-4 inhibitors, their effects is usually greater in Asians than other ethnic groups. But we have to, I'd like to mention that these phenomenon can be observed in those with low BMI of less than 30. So the differences in insulin secretory defect and insulin resistance could lead to better response to DPP-4 inhibitors in Asians. I can summarize like that. So DPP-4 inhibitors have been shown a favorable safety and tolerability spectrum that could be justifies the wide use of the class in wide spectrum of diabetes patients. And during the last part, I'm going to talk in more detail about the gemiglutine effects. These are the structures of gemiglutine, and the DPP-4 inhibitors are usually classified into 3 classes depending on their structure and mode of action. In addition to the well-known binding sites such as S1 and S2, they have some differing. The classic type 1 classes such as vildagliptin and saxagliptin, they usually bind to S1 and S2. Class 2, or such as allogliptin and linagliptin, they have additional bindings such as S1 prime and S2 prime. And in case of class 3, such as gemigliptin, sitagliptin, and teneligliptin, in addition to the S1 and S2, they also have such diverse bindings such as S2 extensive. Compared to S1 prime and S2 prime, the S2 extensive shows the specificity because of the proximity of the classic S1 and S2 binding sites. So gemigliptin of class 3 agents can be regarded to have tight binding characteristics in their binding pocket to the enzyme. And they also show the potent glucose lowering efficacy, either in monotherapy, dual, triple therapy, or insulin combination in any kind of clinical trials. So there can be a natural question at this moment. Then, this, as I mentioned, this is a era of cardiovascular outcomes trials. Do you have any evidence for gemagliptin showing the benefits of cardiovascular outcomes? Well, there's no prospective data so far, but they have real-world data from Korea. One is from the big data, the National Health Insurance Service claims data analysis, and the other is observational prospective study called Optimus. I'm going to briefly mention on these studies. The first one is the real-world data comparing gemagliptin and other DPP-4 inhibitors in terms of the cardiovascular safety from the Korean National Health Insurance claims database. The follow-up period, the observation period was 2 years, and they compared diverse kinds of DPP-4 inhibitors, especially gemagliptin versus other ones, other DPP-4 inhibitors as shown in this slide, and compared to sitagliptin, which is this is the comparison standard, and compared to the sitagliptin, the hazard ratio are significantly decreased, lower in case of saxagliptin, linagliptin, and gemagliptin as shown in this slide. Yeah, this is also the similar result. This is the Optimus study. This is an observational one-arm study to evaluate cardiovascular outcomes in patients with type 2 diabetes treated with gemagliptin. Multi-center cohort study. The mean observation period is 2 to 4.5 years, and 3-point MACE was primary endpoints. As shown in this slide, their incidence rate of 3-point MACE at month 54 was 1.35%, which is quite low, which can be regarded as very low compared to other agents. And among gemagliptin users, there are such kind of hierarchy, such as in case of gemi-sulfonylurea combination, there is a small but significant increase in the risk of MACE compared to other combinations at all. And this is the average A1C level over 4-year periods. In case of gemagliptin, 50 milligrams one tablet. So I think I don't need to summarize in detail because they have their own story for long time periods, and they have many publications so far. And I'd like to thank you for the kind attention. And if you have any questions or comments, you are welcome, and I'd like to accept and I'd like to answer their questions. Thank you very much.
As a new and innovative diabetes treatment, ZemiGlow is an optimized DPP-4 inhibitor developed by LG Life Sciences. LG Life Sciences exclusive ZemiGlow selectively binds to DPP-4 enzyme, among other DPP enzyme family. Through its unique chemical structure, ZemiGlow has stable triangular binding bridges on the pocket and up and down solid binding bridges on the other pocket at the same time. So due to this structure, Zimiglo can strongly and stably bind to DPP4 enzyme. Such as tight binding and long-acting characteristics of Zimiglo leads to significant increase in DPP4 inhibition rate. Thus, Zimiglo can result in high increase of active GLP-1 level. With this in mind, you can expect the following features and advantages with Zimiglo. Firstly, Zimiglo can lead to potent HbA1c lowering efficacy in various regimens. Also, rather than other oral anti-diabetic drugs, such as sulfonylureas, Zimiglo shows more stable glycemic control. Thirdly, Zimiglo has various effects beyond glycemic control, such as renal protection and lipid control. With its selectively binding to DPP4 enzyme, Zimiglo has a reliable safety. Moreover, Zimiglo has relatively balanced clearance mechanism, so that its concentration does not change even one of elimination routes is blocked. This guarantees the safety of Zimiglo. Therefore, dose adjustment is not required for the patients with renal and hepatic impairment. Taking a single pill once a day is enough. Zimiglo is an optimized treatment for type 2 diabetic patients. Potent efficacy. Stable glycemic control. Beyond glycemic control. Reliable safety. Better compliance. Experience the optimized DPP4 inhibitor, Zimiglo.